Hey guys, welcome to this session on predictive analysis using Python. In this session, we'll take a look at what predictive analysis is and how you can use it using Python. Predictive analysis is one of the most important concepts in data science and machine learning. However, it can be a bit daunting to understand what it actually means. Keeping that in mind, we've come up with this session to help you get started with predictive analysis using Python. So let's take a look at the agenda for the session. So in this session, we'll begin by taking a look at what predictive analysis is. Then we'll take a look at why would we want to use predictive analysis. Then we'll take a look at few of the use cases where predictive analysis is useful. Then we'll take a look at the steps that are needed to perform predictive analysis, or what are the steps involved in performing predictive analysis. And finally, we'll have a demo. In the demo, we'll be using Python and Jupyter Notebook and a dataset to do predictive analysis on. So let's take a look at what is predictive analysis. So predictive analysis, quite simply, is just the field of data science that involves making predictions about future events. So you have some data right now and you want this data, you want to use this data so that in future, if new data comes in, you can make predictions on it. That's predictive analysis. Basically, you can make predictions for future events. So that's the way you use predictive analysis, and it's very easy to use as well. It allows us to create a model using our data so that when future data comes into our sites, we can make sure that we can understand what the impact of that data point will be. So in predictive analysis, we use a variety of statistical techniques, data mining, predictive modeling, and machine learning. We use a lot of these concepts and they help us make sure that we are getting the correct prediction, and those predictions can then help us inform our decisions. So why would you want to do predictive analysis? Well, predictive analysis, if it's done correctly, can offer several benefits. Here are a few of them, so let's discuss them. The first one is feedback. So predictive analysis provides you with immediate feedback. So let's say that you have an application that you have deployed in production and you have created a new feature in it that you have allowed a few users to beta test. How has the response been and how will the response go in future? So you have tested it with 10 people and they have liked it in particular geographical region. You tested it with 5 other people in other geographical region, they didn't like it, and so on and so forth. So you have all the data collected. Now you model it based on that, and then you make predictions and you try and understand, okay, what kind of features would be best suited for what kind of region, and in future if we create these kinds of features, where could they be deployed to? So they give you predictive analysis allows you to have immediate feedback. Similarly, if you are in sales or marketing and you have deployed a sales or marketing strategy so that your current product can be marketed across several fields and you get the data and responses back, you can very easily use predictive modeling to understand what the trend is, how much are people liking it, will the current trend sustain for a long time or will it drop suddenly, what is going to happen in the future, instead of you having to wait to see what the trend will indicate. You can just take a look at the data and then figure out what it would be. Then comes optimization. So if, for instance, if we carry forward our sales example, if you are using sales and marketing for a particular product, for the advertisement of a particular product, and a particular advertisement is being used by you, but that advertisement isn't generating enough views or enough revenue as much as you would have thought. So now the time comes to optimize your strategy, and that is done using predictive analysis. Take a look at the data, you create a new campaign, you use that campaign, get the data and make the predictions, compare the predictions with the previous one, and if it performs better for the same number of days that the previous one did, that means that your current strategy is more optimized than the previous one. And with this feedback and optimization loop, you end up with better strategies. You can do it with multiple departments, you can do it with multiple strategies, you can do it with multiple groups of people, and it could lead to better results and better decisions. And these better strategies could help inform business about how to make future strategies as well. And then there's risk reduction. So risk reduction basically means that if you were someone who had deployed a marketing strategy, but the problem now becomes that you cannot take a look at the effects that it's going to have. Suppose you can't do predictive analysis or you don't know how to, then the only option you have is to just wait and see, pour in more money and see how this marketing strategy performs. That's essentially, if it's not going to perform well and you could have figured it out better, then that means there's a higher risk of you burning out your cash. On the other hand, if you can use predictive analysis and make sure that the strategy is performing the way you intend it to perform, then you can be assured that okay, the strategy is performing the way I wish for it to perform. That means my money is being invested in the correct area. So these are some of the advantages. There could be others as well, but that's only if you have been doing predictive analysis correctly and you're getting the correct response. Now let's take a look at few of the use cases of predictive analysis. So predictive analysis has several use cases. It's used across several domains in several fields. Here are a few of them. The first one is churn prevention. So churn prevention basically allows you to figure out whether or not a customer will leave your service. If you are, for instance, working in Netflix, customer churn would be customer unsubscribing to your service, customer leaving their subscription, not paying fees for further coming months, and that means that the customer has churned. So based on customer usage, you can figure out whether or not the customer is deviating away from your service, and using that you can offer up new services. You can ask them what could be improved. You could even offer them offers that would help entice them and keep them in the service for a longer period of time. Then comes quality assurance. Similar to customer churning, you can take a look at quality assurance by using your applications. So if you are using an application or you deployed a service and you are not sure whether or not how customers feel, you can gather data using forms, you can gather data using surveys, using focus groups, and using that data you can then use some predictive modeling and predictive analysis to understand what exactly is it that people want and what are the different kinds of people who want different kinds of features, which kind of features are used by people who bring in the most money, and what should we do about the features that they want. And you can go on about this and try and figure out what's the best way to improve the quality of the service that you are providing. Then there's risk modeling. So as we have already seen that there are certain areas in which having a clear idea of how things are going to go in the future can be really beneficial. And in this scenario, risk modeling refers to that. What risk and modeling allows us to do is it allows us to figure out how much risk is going to be involved in investing in a particular strategy, investing money or time, however, but it could lead to drastic results in whether or not we should invest in a particular technology or a strategy or not. So if we take a look at a strategy that has been used before and we choose to put more money into it, if we model it first and try and understand how the trends are going and if it's going to continue to increase or decrease, that way we can probably do risk modeling. Then comes sales forecasting. So this one is the easiest to understand. If you have historical data about sales, you could do predictive analysis to make forecast about how the sales is going to go for the coming week or the coming month, and that way we can just, after predicting the sales, we can very easily make changes if changes are necessary in the sales in our sales strategy. So now let's take a look at few of the steps involved in predictive analysis. So predictive analysis is a process that involves several steps. First step is problem definition. So what is problem definition? So basically it means we try and define what the problem it is we're trying to solve. When we're trying to make predictions about whether or not a customer is churning, we need a particular set of data and we need a particular mindset. If, for instance, we don't define the problem upfront, we could end up investing a lot of resources into solving a problem that wasn't necessarily the one that we needed to solve. So it's good to have problem definition, and the entire team that's working for the development of a predictive analytic model needs to be on the same page when it comes to problem definition. They should all know what the problem is that they are trying to solve. When it comes to data gathering, this is an important aspect, mainly because if the quality of data that you have gathered is not good, the model that you are getting is not going to be good either. So what we do is we take the data and we use that data. We take data from multiple sources and then we gather it, and the more data that we have, the better. The more data we have means there's more data to analyze and the more data to take a look at, clean, and perform the other following steps. But still, the more data we have means after all the steps we'll still have higher volume of data which we can use to train our model. Then comes data cleaning. So data cleaning basically means after we have gathered the data, we take a look at the missing values, we take a look at the values that are not important, or are the values that are incorrect, and we remove those values, including outliers, minimum values that are higher or lower than the minimum or maximum values that we need, so on and so forth. So data cleaning allows us to improve the quality of the data that we have, which in turn improves the quality of the model. Then comes data analysis. Data analysis is quite easy to understand. Data analysis basically means that we take the data and we analyze it. After cleaning it, we try and figure out whether or not the data that we have is biased on particular regions. Is it going to work correctly? Does it have proper values or not? So on and so forth. Then comes data modeling. Modeling is basically when we train the model using the data that we have gathered, cleaned, and analyzed. Using data modeling, we basically just take the data and we create a machine learning model using the pre-existing algorithms that we have. Then comes testing. The model that we have created may or may not perform correctly. So to check whether or not it's performing up to a satisfactory level, we set aside some data for testing. That data set is something that the model has not seen in its training phase or the modeling phase. And then what happens is we show it the data and we already know the output that the data should produce. And then we give it to the model. The model then produces the output. We compare the output and figure out whether or not the output is correct and how incorrect is the output. And based on that, we give it an accuracy score, which ranges from 0 to 1, 0 meaning 0%, 1 meaning 100%. And finally, once we have a model that is performing up to a satisfactory accuracy score, then we deploy it. Deployment allows us to use our model in production in our applications or allow other developers to use our application. So now let's take a look at a demo. I have a Jupyter notebook available for you and I've written the code already so that you don't have to see me going through the code and you don't have to figure out how I'm doing things. So firstly, I'll just import all the libraries. So let me just tell you what I'm importing. Importing pandas, I'm importing numpy, I'm importing train test split, accuracy score, logistic regression, which is the model that I'll be using, Seaborn, matplotlib for data analysis, and I'm configuring matplotlib to work with Jupyter Notebook correctly. So let's take a look at the data first. This is the data that we have. It's the data that's gathered from a banking campaign. What they have done is they have created a special kind of campaign in which they have created a specific offer. And you want to check whether and they have called a few customers and told them whether or not they're interested. Using this, we have created a model in which we can feed the information of a customer. We have to create a model using which we can feed in customer data from age till the previous one, and using these data sets we can then figure out whether or not the person will accept our offer or not, whether or not the person will enroll in our offer or whether or not they'll just say no. So using this idea, the customers who will say yes will be the customers that will follow up on, and the customers who will say no will be the customers that we won't follow up on, or we won't follow up on that quickly. So we get the data using dataset.csv, which is a CSV file that contains the data. Here's the top 5 rows. The delimiter I'm using is semicolon because the data that I got from Kaggle had semicolon instead of commas, and that could lead to some error. And I've set the headers to infer because it already has the headers on the CSV file, so I just told it to infer the header. So this is the first 5 rows. We have data such as age, job, marital status, education, and many other things. Now let's create a pair plot and try and visualize our data. Pair plot basically takes a lot of our data and tries to pair it with other kinds of data and creates bar plot and other kinds of plot. So pair plot, since we're creating a lot of visualizations and the data that we have is large, it could take a bit of time to generate. So as you can see that it is generating, but it could take a bit of time to make the generation. Yeah, and it has generated everything that we need. So it has used all the columns that we want and has paired it with every other column. So for instance, here's age paired with age itself, and here we have the distribution of our ages. We can zoom into it if you want to by getting a particular kind of plot. Here age is scattered with balance. Nothing interesting is being shown in these plots, mainly because the data set is quite lenient. It's quite clean. We don't have to do a lot of the things that we might need to, but there are a few things that could cause some issues. So firstly, let's take a look at correlation. For those of you who are unaware, correlation basically means how interrelated our columns are. When we're trying to do predictive modeling, we want to have low correlation. Correlation ranges from -1 to +1. -1 meaning that two columns have relationships among each other. such that if value in one column increases, the value in other column will decrease, which means that value in one column will influence the value of other column. To give you an example, if you were to take a look at something like age and height, as a person's age increases, their height increases as well, depending on how the data has been given. But in most cases, it does. So it would have a high positive correlation. Similarly, age and bone density will lead to negative correlation because as the age increases, the bone density starts to decrease. So these are the two ways we can do it. Negative correlation ranges from 0 to -1. Positive correlation ranges from 0 to +1. And 0 means no correlation at all. Now, this is the correlation matrix that we have gotten, which means that these are the correlation values that we have gotten among several columns that we have. So if we correlate age with age, since we're correlating it with itself, it's a 100% match, and one correlation is what we've gotten. For age and balance, it's 0.08, which means 8%, and so on and so forth. It's little difficult to visualize, so we'll be using Seaborn's heat map. As you can see, if I run this, everything on the diagonal has the highest value. The values with the darker tones are the ones in the negative region. The one with the lighter tones are the ones with positive and higher value. So as you can see, there's a good bit of correlation between P days and previous. Now, it doesn't really matter, mainly because the correlation isn't that much to be concerned about. If it was somewhere around the age of 0.7, then that would have caused a problem. But we can do without it. Now let's take a look at the type of data that we have stored in each column. So as you can see, age is integer, but job, marital status, education, default, balance is also integer. But others are objects, which means they contain either data of different kinds or string values. That could be a bit problematic. So what we can do is we are just taking these columns: job, marital, education, default, housing, loan, contact, month, and P outcome and Y. So firstly, we'll go till P outcome, and we will use pandas' get dummies function. What it will do is, let me just show you. These are the columns that we have right now. And finally, for the Y column, we have values of yes and no, and we just replace yes to 1 and no to 0, and we do it in place. Now, what the get dummies function does is that it takes a look at all the unique values and creates separate columns for those. So for education column, which is the third one, what we get is, yeah, here it is. So primary education, secondary education, tertiary education, and unknown education, and it gives all of them the value of 1 and 0. So if someone has a primary education, then the value will be 1 in that column. If someone has secondary education, then the value in that column would be 1, and so on and so forth. So it basically encodes our data and allows us to convert our data into numerical format. The reason why it needs to be in numerical format is because if it's not in numerical format, then the data that we have is not going to be fed into our model. Models only understand numerical data because it's easier to perform mathematical operations on numerical data. So we take that and we get that. Then here's the shape of our data. So we have around 4,500 rows and 17 columns now after we have encoded our data. Now we take a look at the education of a person. We try to analyze what the education is because that seems to be important. So we have primary, secondary, tertiary, and unknown, these 4 values. These are the 4 unique values. If you take a look at the distribution, 614 people who have said no are primary educated, and yes said not are the people who are primary educated. Then out of the secondary education one, 2061 who said no are educated till secondary level, and 245 are educated till secondary level. So no means that that customer has said no, and yes means the customer has said yes. For tertiary education level, 1,157 people said no, and 193 people said yes. And finally, this is the value of our people whose education status is unknown. So now if we were to plot this using a bar graph that is horizontal, we can see this. Here's the bar graph that we can see. And as we can see, people with secondary education provide a much more bang for the buck, or you could think that we have higher number of people who are secondary education. Now what we do is we create a data frame out of X and Y. Y is the thing that we're trying to predict whether or not customer will say yes or no, and all the other columns are X. These are the columns that the customer will feed into into our model, and we will predict the output as yes or no. So this is what the columns will look like. All the columns from age till P outcome unknown is the one that we use, and for the Y column we have second data Y. Now we split it into 30 and 70 ratio. 30% of the data is for testing, 70% of the data is for training. And here's the number of rows in each one: 3,164 rows in the training set and 1,357 rows in the testing set. So after we have done this, we create a logistic regression classifier. We train it, we make the predictions, and we check the accuracy. Let's take a look at the predictions to understand what actually happened. So these are the predictions. 0 means that the customer will not say yes. 1 means that the customer will say yes. Similarly, if we take a look at Y test, here are the customers. So as you can see, it has randomly picked all the customers that we needed, and the first three values here are shown to be 0, and they are 0, which means these three were correctly classified. And the last values 100, and we have 100. So these were correctly classified. The first three and last three are correctly classified. So that's how you can do predictive analysis. Now all we have to do is we have to get data from the customer, convert it into this format, which is quite easy using our pandas.getDummies function. After doing that, we will feed it to our model. That model will then make the predictions here, and will get the responses either 0 or 1. 0 meaning that the users will not be interested in the offer that we are presenting them. 1 meaning that the customer will be interested in the offer that we are presenting. And when we have presented the offer, then what we can do is we can try and figure out, okay, so if this customer base is going to be interested, we are going to focus more on pitching this idea on these customers. And the customers who either our model predicts to be not interested, we would either take a look, we will either not bother them, or we'll take a look at them after some time. So that's predictive analysis that allows you to do this is how you can do predictive analysis: get the data, analyze the data, clean the data, then model your data, train your data, predict that, make the predictions, and finally you can deploy it if you wish to. So now let's take a look at what else we have.